Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, episode 34, Databases. Take it away, Jason.
Hey everyone, so just real quick, I know we promised the episode on Swift. It is coming. Patrick and I are desperately it's coming swiftly. Patrick and I are desperately trying to learn Swift, but it's taking a little bit longer than definitely I anticipated. More just because we wanted to. There's not a whole lot out there, right? And so a lot of it is just understanding how the language works and things like that. So we'll definitely get to that. But in the meantime, we'll definitely we have a really awesome show here on databases that
I don't know what you're talking about, man. I already wrote 3 top of the chart performing App Store games.
Oh yeah, Flappy Patrick.
Yep, and I quit my job and I'm a billionaire.
Oh man. So from the mailbag, Ash Booth wrote in, and he was said, "Hey guys, I discovered the show about a month ago. I'm an AI/machine learning PhD student, and what's it like to go from academia to industry to working? Well, they're both working, but what's it like to go from working at a university or studying at a university to a full-time job?"
Maybe I should answer this because you went straight from elementary school to working, right?
I did have a job for most of high school and college, full-time job. Anyways, you go first, and then I'll chime in.
I was just joking, actually.
Okay. Well,
so for me, I only did undergraduate, so 4 years of college. So I'm not an academic, long-term student.
Well,
so
you did a master's, right?
What I did a master's while I was working. So.
Oh, I see. So you kind of did. Yeah, that makes sense.
So I already started working, and I had an internship actually after my second year of school. So I went to school for 2 years, and I had already worked, and I think that eased some of it. So I recommend internships are a really good thing.
Oh, definitely.
Because engineering internships are almost always paid. I've never heard of an unpaid engineering internship.
Right.
And so you get money. That's cool. And then also, it does expose you for, going back to school for the remainder of the time to, know what to study and what you're interested in and what the real life, I'm doing little quotes here, is all about. But, I think the biggest transition is from the fact that, an academic, it's perfectly to say things like always and never. And in real life, you can't really say those things because you have to bend or break a lot of rules because you may be working on older technology or, the style of your team is just this, and even though academically you may be able to show this paper says this is the more optimal way to do this, it's well, we already coded this, we've already invested the time and tested it, and whatever. Just kind of realizing.
That's a good point. We were talking about this today at lunch that in Python, in the Python compiler, there's something called Tim sort, and it's named after Tim. And the idea is, they need to do some kind of sorting. And again, I'm not going to go into the details. I don't even really know the details. But to some extent, part of the Python compiler needed to sort something. But they knew something about the data. They knew certain chunks of the data were already in some kind of order. And so TimSort, took advantage of some of the assumptions they could make about the data to sort faster than n log n, right? Which, just to recap, if you take Computer Science 101, one of the first things you'll learn is that the 2 fastest sorts, theoretically, quick sort and merge sort, both run in n log n. But TimSort, given the data that TimSort works on, runs in faster than n log n. And so the point is, when you get down to industry, you're not working on theoretical data. You're working on practical data that you can make a lot more assumptions on, and so a lot of the theory kind of goes out the window.
Yep, that's my biggest thing. I don't know.
Yeah, I guess my biggest thing is I kind of look at it this way, like going into academia, like as a student or as a faculty or or as a research assistant or what have you, is a lot like owning your own business. Like as a student, you're really in charge of your own fate more than you are as an employee. Like as a student, you can very quickly, within a matter of 3 or 4 months, you can fail out of college, right? But outside of like sexually harassing someone or something which is very unlikely, like which would require like you to be a sociopath. Like outside of those crazy things, you'll almost never get fired within 3 to 4 months. Like for you to be fired, for most companies, for you to be fired for performance reasons, I mean, you have to actually be.
It takes like 12 months.
Yeah, you have to be messing up for a long time, right? I mean, you really have to be going down the wrong path and know it for a while. But school, I mean, you could, really just like, especially when you get to the higher levels, like a PhD, or even worse, a professor. Like if you don't write, if you don't get enough grants accepted and you don't get enough papers accepted, there are people who want, there are conferences that are looking for good papers, but they're also very selective. And if you don't get these things through, then you don't get funding, and then you have to kind of beg your department to float you, and that ends badly. And it's so easy to fail, just like running your own business, and to just be destroyed in your career. But then on the flip side, what you're given in academia is a lot more freedom. Like in school, you can study whatever you want. If you want to be a biologist, you be a biologist. You study anything. But if you get a job as, say, a software engineer, then obviously it's much more limited, right? So those are sort of the trade-offs.
Well, there's I guess I think about two other things. One is that like in school, almost everything was whatever we call greenfield work. So like everything is completely unwritten, right? You're writing stuff from scratch. And most of the time when you're working on a job, there's already something that exists.
Yeah, that's
it might
true.
just be requirements, but it's very rare. I mean, almost all of my time spent coding is working in other people's code, working in legacy code. Even when I'm writing new code, it has to fit in with other people's code, right? And there is some of that in school, but it's not as much. And then the other thing is like the continuity of work. Like you could be working on the same thing. So at least in like if you're doing graduate work and research, it's probably different. But like an undergraduate, you're doing little projects, but there's typically a long project would last a semester, and most times projects are multiple per semester, right, in a class. And at work, like you could easily be working on basically the same thing for years, but easily, months. And you just every night you go home and you come back the next morning and you're doing the same thing you were like the night before, and you just keep doing it over and over and over again,
Yeah, right. Yeah, actually, there's this interesting TED Talk, and we'll link to it in the show notes. But it's about what makes us feel good about our work. And the reason why I bring it up is they did this experiment where you they had a control group where they started off paying them $5 to build this Lego. So they had a box of Lego, and you had to build something. I think it was like a robot or something, and they had the instructions. And after you built it, they put it aside. They took it to another room, and they gave you a new box and told you to build another one. But this time it was only for, I think it was like $4, and they had some kind of power function, right? And so most people like kept building the robots until it was down to like 70 cents. Then for the second group of people, they had them build the robot, and then they destroyed the robot in front of them, like disassembled it, and had them build it again. And that second group like only built the robot once or twice and then said they were done. And so like grad school is a little bit like being in that second group, because you do a lot of work. A lot of it is alone, and even being a professor, a lot of the work you're really like in your own world. I mean, you have students who are part of your team who kind of report to you, but you're really on your own. And a lot of the work, this is my opinion, so take it with a grain of salt, but a lot of that work kind of gets destroyed. Goes into some research paper, and then hopefully someone in industry picks it up and does something with it. But I felt like there was a lot of that kind of being in that second group. But when you are in industry, it's true that like you sometimes can feel like you're a cog in a much larger machine. But on the flip side, it's like, yes, you're part of a larger machine that's doing something pretty amazing. And so that's sort of like the big trade-off I see. So,
All right, on to news.
News. So this is pretty topical. There's a database, RethinkDB. And the impression I get is, I don't know too much about Rethink, but the impression I get is they're trying to kind of compete with MongoDB and some of these other document stores. And they released a new version that has a bunch of cool new features. So if you've never heard of RethinkDB, after you're done listening to this podcast and you're a database expert, you can definitely check it out.
Oh, we could offer certifications. You're a certified database expert.
Nice. We should team up with Udacity or something.
Oh, I got that email too.
You did? Yeah, I was thinking that. Yeah, anyone who has an Udacity account got emailed a couple days ago from Sebastian Thrun himself, saying that they're going to start offering accreditation.
All right. This next article is yours as well. DHCP.io. What is that?
Yes, DHCP. So I used to use DYN DNS, and actually I still use it. And they stopped doing free host names.
I didn't know that.
Yeah, they stopped. But I had already kind of been using them for a while, and I got kind of nervous because I have like a bunch of things tied to that DNS scripts, things like that. So I just said, forget it. I'll pay them. I think it was like, $20 for the year or something like that. But now I found out about this DHCP.io. I'm going to try it sometime this week. And it looks like it's exactly what DYN DNS used to be, where it's free and you could just you set up some kind of service that updates your IP automatically and things like that. So I'll check it out. I'll report back next show and let you guys know if it's solvent or not. But at least it's good that there's other alternatives out there.
Nice. So my next one was an interesting article I was reading. It's called "Folding a Fractal." So fractals are, I think, for some reason, programmers are fascinated by fractals and mathematicians.
Why do you think that is?
I think because it's just like we don't do, at least a lot of programmers I know they don't consider themselves very artistic, but it's kind of something where you turn a little knob, you change a little equation, and you get something kind of beautiful out.
Okay, that makes sense. It's
like computer generated, like procedurally generated things, right? Programmers will like build all sorts of, I always see procedurally generated, moonscapes and landscapes and treescapes, and people are just like really like a simple algorithm that creates something complex.
Okay.
Conway's Game of Life, right? Like all these things, like complexity from simplicity. And this article takes an interesting look, which I had never heard about before, for the I believe it's the Julia fractal, and basically talks about the symmetry of it and how you always hear the typical thing like a fractal is something that takes place on the complex plane. So the vertical axis is the imaginary component, and the horizontal axis is the real component. I think I'm getting that right. Mm-hmm. And you take a point there and you apply, you put it into an equation, you get a result, and then you take the result and put it back into the same equation. You keep doing that, and either the results will stay under some limit or will kind of spiral out to an infinite number. And based on that, you kind of make colorings, and whether it's in the set or out of the set, and these beautiful things arise. And this one, you typically hear about it in this very mathematical description that it's kind of dry, kind of boring, I guess. But it's interesting. And this one, they talk about it in a way of kind of like folding and transformations, and you'll have to read it. They have some kind of cool animations. They talk about it. And it's just a different way of looking at it, but, kind of interesting that even with a different approach, you can kind of arrive at the same thing and kind of have a different insight in how and why the shapes arise like they do.
Yeah, this is really cool. I'm actually on their website now. This guy's website is incredible.
Yeah, but it's poor performing.
Well, so yeah,
so it's really cool. But I had trouble loading it a couple times.
Yeah, so I was just saying how great it is, and all of a sudden I was rotating his website around. You can actually like move the header of his website around in 3D, and then I got an achievement in the website. I got achievement unlocked for rotating the logo around. But as part of getting that achievement, I broke the website. Like I can't scroll anymore.
Oh, nice.
But I'm looking at the top of his header.
So it is
great.
I mean, it is an interesting website, but it's not my favorite cup of tea, but okay.
Yeah, a little too much going on, but it's pretty cool. I haven't seen a website like that in a while.
So you can check out the link in the show notes, or just search how to fold a Julia fractal.
Yeah, definitely. So, yeah, I have a piece of news here. WavePot music scripting. I have a bunch of friends who are music buffs. I tried to play the guitar once, and it was embarrassing. And I have no musical
Wait,
talent.
Guitar Hero. I'm great. No, I'm not. I'm mediocre at that game.
Well, there you go.
That makes me a real musician.
I'm also mediocre at Guitar Hero. But this is pretty cool. It's basically it's all JavaScript, so you can iterate pretty quickly, and you just write some scripts. Basically they give you a function, and t comes in where t is the current time, and what comes out is an amplitude. And they have a few samples where they just do sine of t, cosine of t, and you can hear the little sine wave mix. And if you do sine of 2t, you can hear like a higher frequency sine wave. And then they even have some crazy examples where it's like they've made their own techno, their own electronic music that you can just execute in the browser. So I thought it was pretty cool.
I've played with something like this before. I'm trying to remember the name of it now. There's like a scripting, same thing, but it's not like live in an editor, but it was kind of like a scripting language that you would use, and it did something very, very similar to this. Interesting.
Yeah, it seems pretty cool. I mean, I know nothing about music theory or anything like that, but this looks really fun. If you're into music and you want to build your own sick techno beats, this seems like a really good way to do it.
Nice. This kind of goes in line with our last one. Man, we have themed news reports. This is good.
Yeah, totally.
All right, time for book of the show.
Book of the show. So my book. I
think you should go first.
All right. I think you should go first.
No, you should go first.
I think you should go first.
Let's make this win-win. Let's talk at the same time.
Let's make a deal. How about I go first of book of the show, and then you go first tool of the show?
Okay.
All right. What we just had there, ladies and gentlemen, was a negotiation. And I won only because I read Negotiating for Dummies. And I talked about this book a long time ago. I'm getting ready to buy a car. We've talked about this on the show in the past, but Patrick and I both have pretty new families. So,
are you getting a minivan?
I don't know. So, I kind of think the minivan is kind of cool, especially because, well, cool isn't the right word, but I like the minivan because it can hold. It's sort of like having a hatchback. Like it could hold bicycles on the back and things like that.
Mm-hmm.
But then I also see the SUV is kind of a nice way to sort of have like a bigger car that could hold more people. But
so do people not like minivans just because they don't think it looks cool? A lot of people really don't like.
Yeah, minivans. I think the problem is I think minivans got such a bad stigma. It sort of like has the whole soccer mom connotation. Like I'm completely indebted to my kids' happiness, and my life doesn't mean anything anymore. That's sort of like, I feel like some people attribute minivans to that, to that idea, and it's obviously not true. It's just a car, but and then so they came up with this SUV where it's like SUV. I think if I understand correctly, it's like a truck chassis. So you could feel like you're driving something with muscle, but it's like It's like, yeah, I have a chassis and a frame that can withstand Arctic tundra, but I'm going to drive, 3 people, in suburbia,
Yeah.
So, um,
So you're relearning how to negotiate so that you don't overpay for your car.
exactly. So, I'm still in the early stages. I'm still trying to figure out what kind of car to get and things like that. But I have this book hot on the fingertips for when I get into that.
So when you show up to the car dealer, you just plop the book down, and then they just like, okay, fine.
Yeah, that's the plan. The plan is to just start actually just reading quotes from the book until they give me the price I want. But no, I thought this book was great. And so it's one of the few books that like I actually use as a reference. Like most of the time, we actually today's day and age, you just look things up online. Like, like we have a lot of books of the show on programming languages and things like that, and they're great, especially if you don't know the language. Like I'm reading the Swift programming guide right now. But like then if
Wait,
at the
as
end
we
of
do the
day,
show?
well, but at the end of the day, if you just forget how to use a function or something, you're not going to use that as your reference. You're just going to Google it. But this is a book where it's like I feel like I keep going back to it, so I figured I would go back to it here and make it a book of the show, which
Nice.
it hasn't been yet. So
My book of the show is a fiction book called Steel Heart by Brandon Sanderson. He writes a lot of books. This guy's crazy. I don't actually know how he writes as many books as he does. Some authors, it's like a long time between books, and he doesn't. He actually has multiple series going. This guy, but like,
how do you think they do that? Like even Terry Pratchett.
oh yeah, he writes a lot of books.
Yeah, how do they do that? It's unbelievable.
And his are mostly Discworld books, but like he does write other books as well.
Yeah,
But this
it's
guy's got
unbelievable.
he's got at least like 3 series going, I think. Like 3 different universes or whatever.
Man,
Maybe
I don't
more.
know how they do it.
And he comes out with like, it seems, I'd have to go look at his, but it seems like every couple months there's a book coming out. Yeah, I don't know. I don't know how people do it. And some people, it's like, I'm reading a trilogy and it's like been like 2 or 3 years since the last book came out. It's like, I really want the next one. The author's saying like it's going to be like another year at least. And it's like,
Yeah.
So sometimes
Didn't
it's
they,
better just to wait till the trilogy's done and then start reading it.
Yeah, the lady who wrote the vampire books, what's it called? The one with the vampires and the werewolves.
Anne Rice, like Interview with a Vampire.
No, the one that they made the movies of. The girl, like she has a vampire and a werewolf, and she doesn't know which one to date. She ends up dating the vampire.
Twilight.
Twilight, that's right. So the lady who wrote Twilight, apparently she was going to write, I guess like another like some kind of epilogue book, but then the book got leaked out, and so she canceled it. And that kind of blew my mind because it's not like you can't cancel a book. I mean, it takes so long. I thought that was pretty wild. It takes so long, and it's such an individual effort that like the idea that even if someone spoiled my book, that I would just throw away a year of my life.
Yeah, but you wouldn't write that kind of book. Nobody's going to spoil your programming book, my friend.
I'm just saying, like, no matter what book I wrote, if somebody spoiled
In the end, it compiles.
if somebody spoiled anything that I spent a year working on, I would still just finish it. But, then again, she's already written so many books, it probably doesn't matter.
Yeah. Some people at that point, like, it's probably not for the money anymore, right? Like,
yeah, I guess if someone spoils it, there's nothing left.
Something happened with the J.K. Rowling, right? The person who wrote Harry Potter wrote another book. Oh, man, I wasn't prepared for this. But she wrote another book, but she wrote it under a pen name. And I think it kind of got, like it was well-reviewed, but not, like, people, like, didn't get excited. It wasn't, like, a bestseller. I'm probably butchering this story. And then, like, kind of came out that she wrote, someone leaked, like, her publisher or something leaked that it was her. And then all of a sudden it was, like, through the roof sales, and all of a sudden it was the great book and all this stuff.
Oh wow.
But like she was trying to dodge it, because she didn't need the money, so she probably just wanted to write and not have people view it in the light of Harry Potter.
Yeah, it's interesting. There was some writer who gave a TED talk recently, it was one of these, like, I think the topic was like, how do you survive your own success or something like that. And basically she just said that like she had like huge writer's block because she was like consumed with like her own success. Like, not that she was gloating over herself every day, but it was more just like she felt like, how can she top that, you know? And the short story is that she just decided to write a book. Like, she kind of just got the cojones to write the book, and the second book tanked. Everyone was like, this is nothing like the first book. And then that sort of like gave her the freedom to write the third book, which ended up being like her best book or something. But
Interesting.
yeah, apparently, like, you know, again, like I was saying, it's such an individual effort that, like, it's sort of like movies, you know. I would imagine, like, at some point you're going to the movie just to see George Clooney, and it doesn't really matter what he does. That's just kind of a weird
so
dynamic.
Coming full circle, Steelheart by Brandon Sanderson, and this is kind of like an interesting take on the comic book supervillain theme.
Oh, okay.
So it's kind of that way, but not like, it's not a Marvel universe. It's not like DC universe. And it's a book, not a comic book, but kind of in that kind of theme, but with some interesting twists on it. So it was nice. It was a good read. It's a rather short book.
Oh, okay. So it's not a comic book. It's
No, but it's like in that kind of world, right? Like same kind of ideas.
Cool.
So I get to go first for tool of the show.
All right.
Mine is Arduino. So we've talked about Arduinos before, and I recently used it for a project, and people at work were giving me a hard time because, you know, everybody's like, oh, Arduino's overpriced, and, you know, you can get this other ARM device, which is 32-bit and 100 megahertz and only $5, you know, and then by the time they finished their discussion, I actually had the project done on my Arduino. And I'm not like, Arduino is the best thing ever. Like, a lot of people try to do stuff with it that you should just move to another processor. But if you're trying to do like rapid prototyping, I've realized how wonderful of a tool it is, because there's so much example code and libraries and peripherals out there that just work with it, and you just do it and it works. And if you need to, it's same thing with kind of Linux distributions in a way. It's nice if there's a big community, because somebody probably asked a question. So it's good if you can ask a question and eventually someone answers it. It's better if you just look for the question and it's already been asked and answered.
Gotcha. With Arduino, don't you have to write in some wacky language, though?
Yeah, but it's basically just C. Like, I just write in C and it works.
Oh, really? Okay.
Sort of. I mean, I don't know. I don't do any, like, applications programming in it, right? So it's all, like, manipulate some hardware is what I'm typically doing with it. And so I'm normally grabbing some library and some example code and changing it just enough to where it works. And is really fast for that. And, you know, I install the IDE, I do the thing, and it's not, I couldn't imagine trying to do a complicated project in it. It would probably be terrible. But like I said, in the time that I could have figured out how to get a compiler installed, properly compiling and properly flashing, and, you know, the bootloader working on a $5 whatever other ARM board, it probably would have been very, very powerful and would have taken me weeks to like get working before I started. And I was done in, you know, like a couple hours for the thing I was trying to do.
Yeah, the Arduino has Wi-Fi, right?
Some versions of it do, yeah.
Yeah, because as long as it has Wi-Fi, you could do almost everything on a desktop. At least, you know, if you're prototyping, you don't really need to have that much logic on the.
I'm not sure where you're going, but yes.
Well, no, I was saying because, you know, if you could do everything on the desktop and just communicate with the Arduino device,
I see. Yeah.
Then you don't have, then the IDE doesn't really matter that much, right?
Yeah, so I mean that's one way to look at it, right? Like some people, even some of the Arduinos have this where they can pretend to be basically a keyboard, right? And so there's interesting like data logger Arduino stuff where you just want to like measure the temperature in your office, right? So you could try to go buy some USB thermometer and figure out some SDK, or you can like hook an Arduino up to it and have it type in the numbers into a spreadsheet and push enter after the end of each reading. It's just kind of an interesting hack, but in some ways is really straightforward and quick. So if it works, it works. And if you need to go to something more complicated, you can, and you'll know sooner. So, and that's why Arduino is my tool of the show. Even for, I don't consider myself an expert programmer, but someone who does a lot of embedded work. Like, if I had a board that was my preferred setup and I went to it all the time, sure, maybe that would be better. But since I don't, when I have to do stuff with hardware and I just need it done, Arduino. Yeah.
Cool. So what's your most recent like home project with Arduino?
With Arduino, so I it's kind of hard to explain. I'll do this other one. So I was trying
Okay.
to. I wanted to build like something for like just like entertainment value to move like a flag back and forth. You can kind of think of it. So I wanted to just like attach a servo motor to a flag and like have it wave the flag, right?
Okay.
Very patriotic. I don't want to have to actually wave the flag, so I build something to wave the flag for me.
So in preparation for July 4th, you're going to have a robotic flag waver.
So it's basically that, yeah. And so I programmed an Arduino and just told it to go from one extreme to the other, back and forth, back and forth, back and forth. And it was done in like, I already had a servo, I had an Arduino board, hacked it together, and it was done. Before that, I built an Arduino that moved 2 stepper motors that were on pulleys for strings, and they were attached to a pen, and they moved the pen around a piece of paper and drew pictures.
What? That sounds amazing.
Oh. Well, it was kind of, the hardware part was interesting, and then like it was just programming after that. It was like, oh, this is kind of boring actually.
So you could give it like a...
So you give it like an image, and then there's already tools. Like people had done this before, which I guess is why it wasn't that interesting to me, because it kind of felt cheap. But like people, you encode it, threshold or whatever, and then you do like traveling salesman problem. Like how do you go from all the point cloud basically to form like a pattern that looks like the image?
Right.
And then you send those coordinates for each of the paths, and the Arduino would move the pen to that, move it, and you just keep streaming the commands over.
That sounds awesome, man. You should document these. I mean, I would love to see a video of that working.
Yeah, but like I said, it was something other people had already done, so it was like I was just following their instructions. I wasn't really adding anything
new. Patrick, we don't know those people. We know you.
Okay. Yes, I'm terrible. I don't contribute back to the internet. I hoard it all away in my head.
Okay. That's pretty awesome. My tool of the show is not definitely not as cool. But I was actually talking to a coworker about sort of productivity tools. I have a bunch of at work I have a bunch of email add-ons and all sorts of email hacks to do all sorts of crazy stuff. I have like this naive Bayes filter that runs on my email, and just to it can actually shave hours off your workday, like if you can get your productivity up, or at least by up I mean like more efficient.
Wait, it doesn't shave hours off your workday. You just get more done in a workday.
Yeah, I guess that's
unless you're like, I don't know, most people you kind of expected to work a certain amount, right? So like if you get done sooner, do you just go home? I typically end up doing
really
more.
So I've never, left at 1 p.m. or something like that, right? But at the same time, I don't really like follow any schedule. I just kind of have this feeling like, okay, now it's time to go.
So you get, instead of working later, you can like go home at a good time and still have gotten done a good work day's worth of work.
Yeah, right. So this tool is called NVAlt. It stands for, there was originally a tool called Notational Velocity. I think the tool still exists. It's for OS X. And it's pretty cool. It uses like this wiki format. So basically you write in this wiki format, and it has this like pane off to the right that has, the rendered format that's updated in real time. And the cool thing about it is it just feels very natural. Like you write what you want the note to be. Then you hit enter, and then you start writing the note, and then it has a search functionality. It has a bunch of cool stuff. The thing is, I don't really like the wiki format. I much prefer Markdown, especially like the GitHub flavored Markdown, like the extended Markdown has tables and things like that. And so NVAlt is a open source alternative to Notational Velocity, which uses Markdown instead of wiki markup. So I use that. I found out, because we were doing the show, I did some research, and there's actually one called NVPy, which also supports Markdown, and it's written in Python, so it works on any OS. So you can actually take notes on Linux, those notes will magically work on OS X or on Windows or what have you. Also, it has sort of this, it can be locked with a password. So in other words, you can put all your notes on, say, like Dropbox or Google Drive or iCloud or what have you, and share them among your computers and not have to worry about somebody who doesn't know the password, getting access to your notes. So it's got, pretty good security there. It has the indexing and all of that. Oh, also you can at any point turn your notes into sort of like a wiki thing. So it'll basically take all of your notes, render the HTML, and then put them in file names based on the title and create a little index. So it's sort of like your own personal wiki that you could publish to the internet. I've never used that feature, but I just think it's kind of cool. Like one of these days I might need that. But yeah, so NV Alt, it's if you need to kind of take notes, whether you're a student or during meetings or something like that. I found that one really useful.
Interesting. I'll have to check that. I don't have a good note-taking app, but I do take lots of notes. Typically on scraps of paper.
I used to use this Emacs extension. I forgot what it was called. But yeah, this is way better than that. So
this is similar to one I've considered before, todo.txt.
Oh, okay.
It's
yeah,
kind
I
of
haven't
similar.
seen that one.
You check that out.
Yeah.
All right, maybe I'll come back with that as a tool to show if I try it.
All right, yeah, let me know. Try this one and try
All right.
I haven't heard of that one, so if that one's better, let me know.
Okay, so on to databases.
Data, big data.
We're going to store this away and update the row containing this podcast file. No.
yeah. I the SQL syntax, for some reason, like, I could use it every day. Like, there are some times where, let's say over the course of a month, I use SQL every day, and I still don't remember the syntax. I don't know why. But I remember there's like select star in table or from table. See, there you go. Anyways, so, before there were databases, which is probably going way back because databases have been around for a long time. Actually, how long? Databases were around in the 1960s. So before that, and up to today even, people use flat files, right? I mean, it makes sense. Like, you just have, if you have some file on your computer, you can actually seek in that file. Like, most files are random access files, as long as you're not using like a tape or something like that. And so you can actually just seek to any point in the file and read that point or write that point. And so a lot of people will just write out like, text files. Like, for example, if you have a web server, every time somebody visits your website, you might append a line to some flat file or raw text file saying who came to your website. And, this is great for a lot of things. But it doesn't do everything. There's a lot of reasons to use a database. One of them is indexing. So the idea here is you have a lot of data in your database. Let's say you have a list of names. So you have Patrick, you have Jason, you have Jennifer, Sophia. You have all these names. A column just full of different people's names. So most of the time you want to look someone up by their name. Like, give me all the Patricks or give me all the Jasons. So what you don't want is to have to look through every name in your whole database and then pull out the Patricks as you see them. Like, you'd want to do some kind of pre-processing and build an index such that when you say, like, give me all the Patricks, it's kind of ready to go. What's the difference between an index and a reverse index? Do you know?
Nope. Don't know.
I don't know. I think so. A reverse index is where I think it works like this. I think, let's say you have a bunch of records. An index says, okay, record 1 has Patrick in it. So if I look for record number 1, I want to get Patrick. Or if I look for record number 1450,000, that one's Jason. That's an index. Like, you're indexing into the database. A reverse index is when you want to go the other way. Like, give me all the Jasons or all the Patricks. So, even a flat file could have indexing because, you could just say, like, every 10 megabytes in the file is a new person.
Yeah, so it's just reverse versus forward. It's just like a matter of how the data is stored versus how it's looked up, kind of, right? So,
yeah,
so like you
exactly.
said, like if you have a log, right? First you just start adding lines to the end of the log, but eventually you want to like have a way to go straight to a given day when it gets really, really big, right? And you don't want to have to parse all the days to find out like where a given day starts. So you may like put up at the top like day 1 is at byte this, day 2 is at byte this, day 3 is at byte this, right? It's like a forward index because it's kind of like the way it's stored. Reverse index would be like if for some reason you wanted to go like the other way, like from a given entry to like know what day it was in, right? Like
right.
So it's not exactly the way it was stored. That data in this case is kind of a bad example because it's probably stored in that portion of the log. But if it wasn't, like, hey, I'm at some part of a file for some reason, I want to go back to like what day it was, like going the other way.
Yeah, exactly. Or like tell me what days user X logged in or something like that.
Yeah.
Then you need a reverse index. So the point is databases do both of these. So you don't have to think about how to build, and it's actually very hard building those structures. So you don't have to think about that. The database will do that for you.
Similarly to what the discussion is, as it typically comes as data grows, right? So like it starts off simple, you do something simple, that's fine. Then as it grows, you start having a problem like caching. So if the file gets really big and you're accessing it in the same way a lot, if it's just a flat file, depending on your RAM and your cache, maybe it's getting caching at like the CPU level. But as it grows like bigger and bigger, right, like you want a more sophisticated caching scheme that understands the access patterns you're likely to have.
Yeah, exactly. Yeah, I mean the CPU will cache in its own like L1 and L2 cache, but these are very small, right? But the a database can cache like 200 megabytes of information in main memory, and it does like the caching between like your hard drive and the main memory, and again the way that most databases do the caching is very sophisticated, so. You don't want to be writing that yourself.
Yep. No. It grows. Like you could write simple caching yourself, but yeah, more complicated. It's better for someone else to have done it.
Yeah, definitely. Another one is redundancy. So, you want all your data to be backed up in real time. Like imagine if you're processing orders, like you're a online furniture store or something. If your computer dies, or even if just the power goes out and you have to your computer hard resets, if somebody's in the middle of an order and you double charge them or you forget to charge them or something, it could be a big deal, right? Or if you lose the entire your all of your data and you have no way to recover, that's a huge disaster, right? And then it gets really tricky because the way you back things up, I mean, you could have infinite loops. Like you could have a student record which points to the classroom they're in, and the classroom points to the students that are in that class. So you can have these sort of like circular references and things like that. And so being able to, back up something like that, some kind of structured data, and to recover it, these things are really tricky, and you don't want to be implementing them yourself.
Similarly, trying to scale them. So running on one computer is all well and good. More memory, more CPU. Eventually that runs out. And now you have to scale to multiple computers, also called distributed databases, right? And now you have a whole host of other problems you got to handle about, do you put one table on one computer and another table on another computer? Or some users' data on one computer and some on another? And then how do you split up that, right? And like starts to play in like a lot of different choices about how you want to scale the data. And, understanding the problem set so that that you're scaling in a way that's going to be beneficial for you.
Yeah, exactly. Yeah, I mean, most of these databases, if you go to Amazon or Microsoft or Google or any of these like big services, I mean, there's a ton of computers that are all working together to store like one collection of information. And yeah, trying to implement that again, really hard. Very hard to get right. Even the experts don't get it right all the time, right? There's a lot of heuristics, a lot of guessing and hoping that certain conditions aren't met and things like that. And there's a lot of fingers that are crossed and so it's definitely not like a solved problem. And you don't want to be in the business of trying to solve it. I mean, unless you're getting a PhD or something in databases. But for the rest of us, we should leave it to the experts. Also segmentation, right? I mean, most people access data um, in certain patterns, and they might only need, if you're looking at, say, like SQL, which we'll talk about later, you might only need one column at a time, or you might not select all the columns. And so SQL can actually say, even though this one row of data is kind of one atomic thing, I'm going to break it up into pieces. Or, as Patrick said earlier, I'm going to break each day and put each day in a different place. And it can look at sort of your access patterns and also some hints that you can give the database. And it can, divide your data, segment your data into different pieces such that it doesn't have to do a lot of extra reading. It can just read the parts that you want and do that very efficiently.
And I guess it should be pointed out, some of this we're blurring a little bit, and maybe it doesn't matter, between database and a database management system. So,
that's a good point.
In some way,
but
yeah, go ahead.
Oh, I was just gonna say the it's kind of a whole package, right?
Yeah, but in some ways, like, a database is a theoretical design thing, right? Like, for a relational database, I'm defining, here's my schema, here are my relations, here are my constraints, and right. I want some physical implementation of that, but you could arguably have different front ends that handle it differently based on like how stuff is getting put in or taken out. But in reality, I don't know of anyone who does that for any practical reasons. Typically, you have one database management system, which is also managing kind of like the database, the back end. But database management system is where things like what Jason was talking about, like observing usage patterns and deciding what to go ahead and pull out a priori, say like, oh, I know you might going to look at this next. That would be something that the management system would be handling versus like the database itself may have less of an influence on that.
Yeah, that makes sense.
I don't know. That may be arbitrary. The other thing that is really good for a database is like, so initially you start off, kind of storing data, retrieving data. But then as you have like more users and more data, you want to do analysis. You want to say like, what kind of trends do I have? How many users are visiting my website each day? Is it growing or shrinking? What regions? And the more ways you want to slice and dice and analyze your numbers, the more you're going to want them to be in a database, which it's kind of understood how to write queries to do this. Otherwise, you end up re-implementing a lot of that yourself over your whatever your other implementation of storing your data is.
Yeah, that makes sense. Yeah, a lot of the database-driven languages are designed for people who want to extract meaningful information from their data. And yeah, you're gonna have to be re-implementing that, which is not fun. Another one, we'll just kind of round this out, is validation. So, there's a lot of database management systems support triggers. So in other words, if say or an entry is written for a credit card transaction and it links to some credit card, but then that credit card isn't there, then what that means is clearly like some system has made some mistake, because it's tried to reference a credit card doesn't exist. So you could have some trigger that says, when I see a credit card, ID for a credit card that's not in the credit card, part of the database, then, send an email or page somebody or something like that. Also, you could do client-side. Well, I don't know if you'd really call this client-side, but you could do sort of immediate validation, right? So if somebody tries to insert a record, without inserting its sister record that it's joined with, or some other kind of validation, somebody puts a negative age in the age column, or something like that, then it just won't accept, that operation. It says, hey, if you're going to put an age, it has to be, at least 0. It has to be a non-negative number. So, a lot of these types of validation, this type of validation logic is very easy to do. They make it very easy and practical, these are all things that you'd have to write manually in C++ or something like that if you're writing your own database.
So we're going to start talking about the different types of databases. And one thing to mention as a side note, and it's a very detailed subject, so maybe we'll just kind of gloss over it. is the issue of consistency. So this is when, a single person is updating, or a single user computer process is updating your database. You typically don't run into this problem, but it's when you have multiple users that you begin to have an issue. And consistency, the kind of gold standard, I guess, is ACID compliance, which is atomicity or atomic things, consistent, which is, I kind of grouped them all in together, but I guess consistency is one part of it. Isolation and durability. And we won't go through what each one means. You can read about it, and they have very precise definitions. But these are basically that what happens, what are the guarantees I can say about when I successfully insert a row or update, what do I know has happened or not happened? So like if you think about a bank, both my wife and I can go use the same ATM card, or my ATM card and her ATM card, which link to the same accounts, and we can try to draw money at the same time. And the system needs to be very carefully set so that we aren't able to draw, both the full amount, or the bank will end up giving us too much money. And so in that case, you want to make sure that you understand what happens when there are parallel transactions occurring.
Right. I mean, in Patrick's case, the transaction's happening very slowly. But here, I mean, there could be millions, maybe billions of people accessing your database. And so it becomes very likely that two people, try to delete the same thing at exactly the same time. And so that could be very difficult to handle, right? Or two people trying to insert the same thing at the same time. Or you're in the middle of an operation and the power goes out. These are all just very difficult things to handle. And a lot of thought has gone into sort of how to deal with that. So yeah, there's many different types of databases. Getting back to Patrick's point, this is sort of more, we're going to talk about the actual database side, and then we'll get to some implementations of management systems later on. But the two that I think most people will be familiar with are relational databases and then everything else, which everything else, you've heard maybe NoSQL databases, but basically that's sort of a catch-all for just a varied assortment of other databases. And it just happens that because of changes in computation and networking, and in sort of the Moore's law kind of fading and things becoming more distributed, the NoSQL databases have become much more important, and so we'll cover those in general. So why don't you go first? What's a SQL database?
I mean, I think if you know database, any kind of database is the one you're likely to know. So SQL is the structured query language. This is where you see select star from the table name, where some limits you put on the query, and the query runs. And similarly, there's a schema associated with it. So when you create tables and you have constraints, and some of this is particular to a database management system, and some of it is part of like a standards-based language that you can use. And there are all sorts of things which support SQL-like languages. So you can write a query like what I just described, select star from users where creation date is yesterday. Something like that. It's a very common way. A lot of things use this because it's a very straightforward notion. But ultimately underlying it, the relational part says, how do I provide links between two tables? Right. And it gets into what you'll hear the term normalized and denormalized data, and patterns for that. So you want to be efficient in saying, like, if I have a teacher and a teacher has a bunch of students, the students also have classes, right? You can try to model, kind of each row contains all the data necessary, but you're replicating a lot of information and you're not representing the relationships there. That there is a teacher entity, and a teacher entity is linked to student entities and linked to class entities, and those relationships can be one-to-one, many-to-one, one-to-many, many-to-many, right? You can kind of have constraints about what those things are like, and keys that index into other tables. So like a student ID is the key, and that might be what you would store in a class roster, a teacher students, and then there might be like a student record which is keyed by student ID and contains like the student's address and their billing status, that kind of stuff. And that is the traditional relational database structure. And you use SQL to interface and do what, joins between these tables to construct the information necessary to get the query to run and the information that you are looking for out, whether it be to look up a specific set of information or do analysis.
Yeah, definitely. So a lot of SQL and these kind of things is, as Patrick was saying, around this concept of IDs and doing joins. So for example, you might have, say, a students table, and it has a record for every student, but then that record also has what's called a unique ID. So Patrick and all of his grades and things like that might be in the student table, and it might be given an ID of like 123. And then in the classroom table, you might have each classroom also has its own unique ID, and the classroom has a list of students, but instead of putting the whole student record there, you could just refer to them by ID. So, you could say, okay, in this class, there is student 123, student 456, so on and so forth. And then you could take that list of IDs and go back to the student table and say, okay, who is 123? And so this sort of breaks a lot of these like circular dependencies or having to have the same information twice, is by storing a lot of these almost like pointers. And there's very efficient ways of looking up things by their ID and things like that.
So then we get to every other kind of database in the world as it seems now.
So NoSQL databases have really taken over for a variety of reasons. There's several of them. One is key value store, and this is the oldest. I mean, this might even predate SQL databases, but this is a very simple idea. Imagine like if you had a SQL table with just one column, right? Well, you had, I guess, two columns, the ID and then some other column. So that's all a key value store is. You give it the key and it spits back the value. And so you could think of this almost like a cache. Most caches are key value stores. And so even though it's very intuitive, it's one of the oldest types of databases, it actually proves to be very effective. There's something called a column family database, which is similar to a key value store, but the idea is for one key there may be many values. So again, if you look at, say, a SQL database, you have a student record, and you might have the key for that record and then a bunch of other columns with information, just student name, grades, so on and so forth. A column family is very similar, where you have like a student ID, and then you also have a set of values about that student. The only difference is in SQL, the idea is that the ID itself doesn't contain any information. So in other words, like Patrick might be given an ID of 123, but that, like, the application shouldn't know or care about that ID. It's just a number that is used in the database to look up Patrick. And it's even, most of the time, it's given by the database. The application can't assign that unique ID. And it's the IDs are chosen in a way which make indexing and things like that really easy. With a column family or a key value store, the assumption is that the key itself is important. So in other words, I'm not going to say Patrick is 123. Patrick, the name, could be the key, and then the value is all the information on Patrick. And so you can actually have multiple keys with the same name. And there could be collisions there that have to get sorted out. Depending on how the management system works, the key might have to be unique. But the idea there is with the column families that the key and the key value stores that the key matters. Thirdly, there's a document store, and this is something that's becoming much more common recently. But the idea of the document store is that it's much more unstructured. So if you were to think of, say, XML or JSON or something like that, um, you can represent a variety of things in XML or JSON, and you could have a collection of JSON objects which have different topologies, right? So in other words, like, I could have one document in a document store which is the Patrick document and has like a list of Patrick's grades, but then I could have another document in the same database which has JSON and doesn't have grades. It has something completely different because for whatever reason. So in the case of document store, it's much looser, and just through advances in the technology and also computation power growing, we're able to have these more sophisticated database management systems that can do all of the things we talked about, the validation, the indexing, the caching, without having such a tight schema as we do with SQL. So even with such a loose schema as you have in a document store, given the right kind of resources and things like that, you can still do a lot of the things that we said at the beginning.
All right, so now quickly as like an overcap, we'll talk about, because you may be thinking of a given database and like, oh, I wonder what it is, or maybe we just mentioned some databases you might be interested in looking up. We're going to kind of go through some breakdown of the various implementations of the databases and some examples if we can give and what kind they are. So first kind of section is the lightweight, embedded, probably only runs on one computer database. And the first example that is very popular is SQLite, SQLite, SQLite. And it is a SQL implementation, a relational database, but it can be even embedded in your program and is super simple to use. And, kind of one of those things, if you start to get any sort of complicated data you're trying to store in your program, you should consider using this instead, because it may make your life easier, and it's quite efficient. It doesn't take, you don't have to run separate server and connect to it. It kind of reduces the complexity of that's necessary.
Yeah, I mean, I think it's even built into some languages. Like, I know Python has SQLite built in.
I didn't know that.
So
nice.
Yeah, I mean, you really don't have to do a lot of work to get it up and running.
And I know Jason's used Berkeley DB for stuff, right? I think you were telling me that.
Yeah, Berkeley DB is pretty cool. Actually, I'll list another one on here, MapDB. And so these are also embedded. So as Patrick was saying, let's say you have some program that you're writing and you need to store some kind of configuration. Like, do people, what sounds do people want when they log in? Or, it's some kind of music app, some kind of like music creation program. What settings do they want their piano set at? These kind of configuration things. These embedded databases are great for that, because you could just load it from a file, store it to a file. It could be part of your program. You don't have to go phone home or something like that. Contact a server or anything. So SQLite is a relational database. So it uses SQL with the structured tables and things like that. If you just want a key value store, so again, like you look up a key, you get a value. Then you can use Berkeley DB or MapDB. Berkeley DB is written in C++, but there are bindings for a bunch of different languages. MapDB is a lot better, but it's written in Java. So if the quick answer is, if you're using Java, use MapDB. If you're using any other language, use Berkeley DB.
Next, we move up the scale to something that you would probably be running on a server. But if you wanted something really fast and your data size was kept under control, but you wanted it to run in memory, you get to your next set of databases. The one that you see all the time on like Hacker News and other websites is Redis. Is that how you say it? I actually don't know, but
I think so.
Okay, it's like all these names. I only ever read them. So
actually, I just happened to, just total coincidence, I went to a Redis meetup, and it is Redis. At least the people there all said Redis.
All right, so Redis, and that's a key value store. So it's gaining a lot of popularity recently. It's pretty lightweight, and it's really fast. if your data size is in the range that you can hold in main memory.
Yeah, keep in mind once you shut down Redis, or even periodically, it saves to disk. So it's not truly in memory where you shut down the computer and you lose everything. But the idea is, at any given time, all of the data is in memory.
Yep. Another one is memcached. I think that's how you say it. Or do you just say memcached? I've heard
I say memcached.
Really?
I
heard
know.
people say memcached, but okay.
It could be. I mean, I've only said it. I've never heard anyone else say it now that I think about it.
Okay.
So I don't know.
This is another one you hear, and this is often when you hear about somebody's having a performance problem with their SQL database, right? We'll talk about some in a second. But, they're having problems because there's some specific data that it just has a higher access rate or different pattern than what, SQL stuff was built to handle. And you'll hear about people talking about this as a way to store data in memory and have very fast access times and kind of alleviate some of the slowness that can happen if you have too many concurrent users to a SQL database.
Right. In contrast with Redis, memcached, when you shut down the machine, it does destroy the database. So the idea with the memcache, as Patrick was saying, is to use to augment another database, and it's for when that database is too slow. So you can imagine things that would be good for memcache would be the front page of your website, things like that. And there's a lot of if you use Ruby on Rails, or if you use a lot of these content management systems, most of them will support memcached, and they will things like the front page of your website they will put in main memory. So
I have no idea why I've heard people say memcached before, because it looks like it's just memcached. You're right.
Oh, did you actually find a pronunciation?
So I was I'm trying to look for it. So I see other people saying that they hear it as memcached. I don't know. I can't find a definitive answer.
I think so memcached makes the most sense because I think it's a memcache daemon. I think that's where the name comes from. But I don't know. I mean, just because it makes sense, it doesn't mean it's right.
So it's kind of silly, but I remember when Linux was first when I first started encountering it, and nobody knew exactly how to say it. None of my friends. This is before YouTube videos, I guess. So you couldn't look on YouTube videos for how to
I
say
remember when people called it Linux.
Yeah, right, exactly. Linux, Linux, Linux. It's people would say weird stuff.
I've never heard that one.
I heard all sorts of strange things.
Linux.
But now I guess there's so much video, right? I don't know or what exactly happened, but I've never heard people say anything other than Linux anymore.
Yeah, that's a good point.
I'm not sure what caused the transition.
Maybe it is, maybe that would be really interesting if YouTube homogenized, language that would be something really interesting to study. I'm sure some linguist is looking into that right now.
Using disk-based server databases.
Yeah, that's right.
So the most obvious one, first ones you think about are MySQL, SQL Server, Postgres. These are ones that a lot of people have heard of. They've been around for a long time. They're some free, some paid, some varying licenses.
Yeah, can you explain? Do you understand the MySQL license?
No, I don't understand. No, don't ask me about any of that. I have no idea.
I mean, it looks to me like if you use the MySQL, client, even the client, then you have to pay them money. That's how I read it, but that can't be true. I don't know.
There are people's whole jobs who are around optimizing and selecting what the differences are between the different databases. I'm not that person. I appreciate those people, but I'm not that.
Yeah, definitely. There's a whole art to making MySQL run the way you want it to, given your data. And Patrick and I are very happy to let people much more qualified than we are do that. So
that is true.
So those are in the SQL family. If you're interested in the column family, which again, just a reminder, that's the key value where there could be multiple values, right? So column family, if you have just one column in the column family, then you have a key value database. So think of the column family as being a superset of what a key value database can do. So in that category, there's two big ones. One is Cassandra, and the other is HBase. The short story is the reason why there's two, they use kind of different technologies for scaling. So in other words, when you have to shard the database among, say, 10 or 100 computers, each of those two, HBase and Cassandra, handle that differently. And let's just say the trade-off there is, Cassandra is easier to set up. Definitely if you're running on one machine, Cassandra is way easier to set up. But even as you scale out, it's the setup and the maintenance is pretty easy. But on the flip side, if you do have performance issues, it can be kind of a nightmare. That's just been my experience. HBase is harder to set up. It actually requires a lot of Apache libraries and services that you have to install manually, like Zookeeper. So you actually have to, install Zookeeper, start a Zookeeper server, and then install HBase and get an HBase server. So this is actually two servers. So it's got overhead, but on the flip side, it just seems like tuning and understanding what's going on is a lot easier with HBase. So that's column family, and then for document store, there's also a bunch of them. My favorite is MongoDB. I really think MongoDB is very clever in their API. I'm a big fan. I felt like, so they have this kind of cool sort of REST-based JSON API. They also have a good Java API. They've recently added full text indexing, which is pretty cool. So you can actually say this column, if I want to be able to do like fuzzy text searches on this column, you can just annotate the column and boom, you get fuzzy text searches. So just to recap, like if the column was, say a web page, let's say one column of your database or one document of your database is a website, all the XML or all the HTML for a website. You could just turn on this full text indexing, and now you have a search engine over the whole web. Now, of course, it's probably not optimized for that much data, but you get the idea. It's still pretty powerful. If you're building your own wiki or something like that, it's pretty cool to kind of get full text searching for free. There's also RethinkDB, which we talked about at the beginning of the show. They're definitely like new guys on the block, so they are kind of iterating very quickly, and I think it'll be pretty cool. But we'll have to sort of wait and see, what they come out with in the future. It's still kind of early.
All right. Well, that about wraps it up. I'm hoping that we didn't repeat too much of what we said when we did query languages, but that was like a long time ago. It's like 14 episodes ago. So hopefully it's not too much of a repeat. And thank you guys for all your emails. Get lots of...
Yeah, definitely.
On our Google Plus page or community. I guess it's a community now. People post on there, and that's cool. We see them. Even if we don't respond, we do see them. And emails to us are always appreciated.
Yeah, thanks, Ash, for your question. That kind of got the whole episode kicked off. So, definitely, post on the community if you have any questions or any feedback or anything like that. We do read it, so and it does give us a lot of inspiration for the show and things like that. We will definitely do Swift as the next episode. We'll have to beef up on our Swift between now and then. But I'm looking forward to that one. So
cool. I think that's a wrap.
All right, cool. See you guys in a couple of weeks. The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.